That was pretty fun. So what we want to do is we want to be able to prove, they're asking us to prove, that line AD is congruent to line CD. That's what they're asking you to prove. All right? Now, obviously, to prove that two sides are equal, we're going to have to be able to prove that the triangles are congruent. Right? Because congruent means they have corresponding sides are going to be congruent, equal in measure. So the first thing we need to do is set up a proof. So we have a statement, and then we have a reason. Interesting. So now, for my statement, for my proof, I start with my givens, yes? Huh? How do you know they're congruent? Yep. Right. But remember, to prove congruence, we need 3. We either need to prove congruence, we need to show that these two angles are side, 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 angle, side, angle, or angle, angle, side. So right now, all we know is an angle and a side. So we got to figure out one more angle or one more side. OK? Well, hold on. Let's go through the whole proof. So the first thing I'm going to do is I'm going to write down our given statements. So we know that AB is congruent to CB. That's very cool. That's a given. The next one, angle A is congruent to angle C. That's given. Then this one is very interesting. It says DB bisects angle ABC. So we look at this, A to B to C. Right? So Terrell, if you're running, got two cornerbacks right in you, and you bisect right in between them to catch the pass, where did you run in according to those two D-backs? Right in between them, right? You bisect. You cut them right in half, right? You split right down, caught the pass. So anyways, when we say a line bisects an angle, what I'm trying to tell you is we can now determine that these two angles are equal in measure. OK? So we can now say that angle ABD is congruent to angle, that's a triangle, angle CBD. Why are they equal? Because that's the definition of bisection. When you know that things bisect, then you can know that we have them done.
No way, no.
Oh, we got an issue. OK. That'll be interesting. So now what we're going to do is we have these two triangles. So now when we look at this, Taylor, is now we can go and see we have angle, side, angle. Angle, side, angle. Right? So now that is one of our congruent statements. So now I can say that triangle CBD is congruent to triangle ABD. Why are those congruent? Because angle, side, angle. However, ladies and gentlemen, that's not what we're trying to prove. We're not trying to prove that the triangles are equal, are congruent. We're trying to prove that AD is congruent to CD. Well, since, ladies and gentlemen, we have congruent triangles, we know that corresponding parts are equal for congruent triangles. So I'm just going to write this a little bit differently, but now I'd write AD is congruent to CD. And the theorem is because the corresponding parts that I'm just going to write there have congruent triangles. Corresponding parts of congruent triangles are equal. OK?